I'd like to first introduce Tom Hengeveld, who is with L3 Harris and is the primary author right now of the link layer encryption draft standards that are being worked on in the APIC encryption task group, and the primary author of the overview document, which we're actually going to be discussing today. And Andy Davis will be joining us as well. Andy is from Motorola Solutions. He's the chair of the TR8 Engineering Committee, which is the engineering committee that's responsible for the what we refer to as the TIA 102 documents, or more importantly, the Project 25 Standards documents. And Tom and Andy will be guiding us through this webinar. And again, if you have a question, please raise your hand and be recognized. And questions are, you're open to questions anytime during the presentation. So right now it looks like we've got a pretty good turnout here of folks. So I'm going to turn it over to Mr. Hengeveld, who's going to start things off with a little bit of a briefing. So Tom, the floor is yours, sir.
Try to share. Can you hear me?
Yes.
Yes,
Okay.
Loud and clear, Tom.
Yeah, hopefully nobody will try to mute me this time. I've been muted a couple times already. Hopefully you can see the screen. It says that you can. This is a presentation with a few additions that I went through at the last TIA meetings in wherever that was, down south somewhere in Florida. So we'll go through it again. I think you've all seen most of this material. Like I said, I added a couple of slides and put in a couple of references to sections of the overview that material comes from. So let's just dive in. So really what we're trying to do here is to give you an overview of link layer encryption as it's imagined today and as it's being standardized today. There's a ton of stuff in these documents. The overview already has a ton of stuff in it, and Andy will walk you through the kind of the roadmap of that later. And I've tried to capture what I think are the important parts that are in the overview. Some of this is also coming from the realization of the standard in the messages and procedures document that we're currently working on. Most of it is up to date. I would say that there may be an item or two that is not. I'll try to point those out if I run into them. We'll go on. The idea with this is to give you a good, solid technical overview of it. At any time, if you have questions or if you want me to go off in another direction, I can certainly try to do that in real time. I'm not a slave to this document at all. So we'll talk about sort of an introduction. What's LLE all about? We'll talk about what the policies for both operators and agencies are that the standard is calling out. There's a whole bunch of stuff where you get to make choices, and those choices we generally refer to as policies. There are some that are applicable to the system as a whole. Those are the operator policies, and there are some that are applicable to user agencies. It's how you program your radio, basically. In most cases, these policies, the important policies, are either entirely local or they're communicated to each other. That is, say, the radio communicates to the network communicates to the radio, the policies that are relevant to it. So we've tried to really kind of minimize the need to coordinate. We're giving each policy a home, basically, one home, not multiple homes, so that it avoids the problem of trying to coordinate policies between different elements of the architecture. We'll talk about the architecture and key derivations. I probably won't go into this in as much detail as is here, because you probably don't care about it as much as it says, in as much detail as is here. And key management methods. Key management is, of course, critical. We'll talk about what we've done from a technology point of view to try to minimize the impact of key management on the operation. What's not here? There's obviously lots of detail that's not here. The 90-page overview you've all had access to. I don't know how many have read it or read the sections that are important, but it's there. That's just the overview. The messages and procedures is much bigger than that. We're happy to entertain questions as we go, and we can have more sessions later, particularly if we find out that that what you're interested in is not this material but other things. I had a discussion with Andy earlier this week. And it may be that what we want to do is in another session later on, talk about this more from the perspective of what the life cycle is of LLE. That is, say, how do I turn it on? What do my radios do? What do I have to do in the real world when things happen? We may want to have another session later on that talks at it from that point of view. But for now, this is what we have. Okay, Andy in his roadmap talked about what is link layer encryption and what is link layer. The link layer is a term that comes from the OSI model, Open Systems something or other, interconnection model for data network protocols. And for our purposes, the link layer is really the MAC layer. The truth of the matter is that the MAC layer is where all of the information converges, all the information from the various services that we have. So that's voice, data, supplementary services, registration, and mobility management services. All of that data converges at the link layer or at the MAC layer, aka the data link layer. And so when you implement link layer encryption, what you're doing is you're giving yourself the ability to protect all of the user information instead of, just one piece of it different from another. So everything in the upper layers, which is 3 through 7, goes through the data link layer to get to its destination. And again, that's everything that's all the user information has to go that way.
It's just a name.
It's just a name, yeah. I mean, Andy said it's just a name. And don't worry about the OSI model too much because, as I say here, layers 5 through 7, I've never had anybody who's been able to give me a cogent explanation or be able to describe in an intelligent way what the difference is between those things. What's important is the bottom layers. It's the physical layer, the MAC layer, and the network layer are the ones that really matter to people. Okay, enough of that. It's a name. It's the MAC layer. It's all the information that is part of a user's world has to pass through there, and that's what we're encrypting. What were we trying to do with link layer encryption? Well, for users, we were trying to provide over-the-air confidentiality for all their data, for all their information, voice, data, control, particularly identities. I mean, we have methods for end-to-end encryption of voice. We have methods for encryption of data, not control so much prior to LLE, but particularly identities. So how do we hide the identities of users from bad actors? We wanted to support what I'll call two-level confidentiality. So you have the data link layer, the link layer encryption, which encrypts everything, but then you still have end-to-end encryption on top of that, right? So if you're doing end-to-end encryption today, which protects you from other users on the same system, you can still do that with LLE. It's applicable to all the air interfaces, trunking, conventional, TDMA, FDMA, common air interface, direct mode, repeat mode. It's applicable to all of them. And it was really important to us to try to maintain backward compatibility with legacy units. What does that mean? That means the target, and I think we've achieved it, was if you have a set of old radios and you deployed LLE infrastructure and new radios that did LLE, the old radios working on that system would not be adversely affected. That is to say, they would all work the way they always had. That was a very important goal for us. With suitable policy controls, we want to have interworking between protected and unprotected subscriber units. Okay, so we divide radios into two classes. There are those that are protected by LLE, the ones that are operating with link layer encryption, and there are the ones that are not. And these could be legacy units, or those could be ones that simply aren't trusted enough to be given the key. So with suitable policies, that is, say, policy controlled by the user that says, yes, it's okay. It's okay for you to talk unencrypted if it's really important. We wanted to make it possible to be able to both communicate securely and to communicate with others that are not secure if that was important. Minimizing administrative burden and really provide agencies with policy control over their subscribers' behaviors. In the operator world, we want to maintain independence between systems while allowing for roaming. So the idea was, if somebody wants to roam via the ISSI in trunking systems, between one system and another, the security policies need to be on an operator by operator basis, on a system by system basis. But you need to be able to admit people from other systems without compromising your own security. So we've worked to make that happen. We allow roaming between protected systems and unprotected systems, again, subject to policy. We allow interworking between link layer encrypted systems and legacy systems. And everywhere we've tried to minimize the administrative burden of link layer encryption, really minimize how much stuff you have to do to make link layer encryption work. And of course, it's 256-bit security. The algorithms are all FIPS compliant, blah, blah, blah. Okay. Any questions about those goals? Really is kind of the scope of what we're trying to accomplish. Okay. All right. So it's important to understand the distinction between what end-to-end encryption does and what link layer encryption does. They are not the same. End-to-end encryption, of course, is providing confidentiality end-to-end. That is to say, when I encrypt a voice at one radio and I send it over the system, over the radio system, and it's received by another, it's protected over that entire route. Only people who have the specific key for the specific group, okay, or have the specific key for an individual communication or whichever, only those people can participate in the call. Nobody else can. It applies to direct mode, transparent repeat, conventional fixed network. Everywhere, end-to-end encryption really is end-to-end. What end-to-end encryption doesn't do is to protect identities. Okay? In order for, in the legacy systems, in current P25, your identity is what gets you access to the system. So you have to broadcast that in the clear because there's no key that's shared between the radio and the site, or between the radio and a conventional fixed station. So it doesn't protect identities. It doesn't provide confidentiality of control messages. We don't have a method today where things like status messaging or other supplementary services, emergency alert, and so on are encrypted. It doesn't provide replay protection. It doesn't provide message integrity, and it doesn't provide non-repudiation. That is to say, you can't say non-repudiation is disavowing what somebody clearly heard you say. Sorry, repudiation is disavowing what somebody clearly heard you say. Non-repudiation prevents you from being able to do that. So end-to-end encryption is a very important tool, obviously. It doesn't do everything, but everything it does well. Contrast that with link layer encryption. What link layer encryption is doing is it's protecting voice, control, data, everything between the radio and the site, between the radio and the conventional fixed station, okay? Between the so anywhere that that So it's only over the air that it's providing security. Okay, within the network, okay, all that stuff is unprotected. Okay, this is why end-to-end encryption is not link layer encryption is not a substitute for end-to-end encryption, because within the network, okay, and as a matter of fact, other users of this system, okay, are able to hear all the transmissions. Okay, there's no grouping in link layer encryption from a encryption key perspective. Okay, everybody on that system, everybody on that trunking site, everybody in the entire system, essentially is part of one crypto group, one group of one security group, and can hear each other. Okay, end-to-end encryption, of course, provides differentiation between the people who are members of, who can participate in this group, and the people that can participate in that group. It does get you replay protection of a sort. There's a time coordinate built into the encryption. It provides identity confidentiality. It provides confidentiality, as I've said, for every single service, and for voice and for data. But it's important to understand those distinctions. It's a single operational cryptonet. It only applies over the air. Any questions about that? Going once, going twice. Sold. Okay. What's protected? We've talked about this generally. I don't want to go into too much detail about it, except on a couple of points. All P25 channel types and protocol data units, data information, are supported. So voice, packet data, trunking control messages, conventional control messages, link control messages, all that stuff is protected. There's a distinction that we make in LLE between protected, unprotected, and legacy SU. A protected radio, so SU is subscriber unit. Forgive me if I'm using acronyms that you're not familiar with. Protected radios support LLE, and they're operating with LLE. That is to say, they have the key, they are fully protected, they're making use of LLE completely. An unprotected radio is one that supports LLE, but is running without it. So there's this notion, particularly in the way we do key provisioning, there's this notion that every now and again, you might have to operate in an unprotected mode, okay? And so when you're unprotected, that we call you an unprotected radio. Legacy radios just don't support LLE at all. So they don't know the messages. They've never seen they have no idea what they're seeing when they see encrypted messages and so on. Legacy SU are unaffected by LLE. Okay. We've made the design fully backwardly compatible. And again, local policy is really governing the degree of interaction between legacy and LLE capable SU. So the policy implemented in the radio manages how a protected LLE radio interacts with one that is not. A couple of terms of art here. You'll hear me talk about all of these. We've talked about subscriber unit capabilities, legacy, unprotected, and protected. There's a thing called an LLE domain. An LLE domain roughly corresponds to a trunking system, or an interconnected conventional system, or any collection of conventional resources that you want. You can build a LLE domain out of a trunking system and direct mode channels. That's a perfectly valid system. And you'll see why that's important when we talk about key management. So even though in conventional there's no WACN or system ID, which is what we're using as part of the LLE domain identifier, a conventional domain is therefore some collection of stations and radios that share a common key and that have a common name, the LLE domain. It's really important that one of the things that we're going to find, I don't know if challenging is the right word, but that we're going to have to be aware of as we start to deploy these systems is the WACN and system IDs really do need to be distinct for systems where users are moving between one and So if you're operating between different systems, radios need to be able to identify that they're in one domain versus another. We'll talk about 3 different trust levels. Trust levels are untrusted. So that's one that is can operate on the system, but it's not authorized for LLE. So a legacy radio, for example. Less trusted, fully trusted SU are ones that that have what we call an RLEC, a root key. So this is kind of like the master key for the system. From the RLEC are derived what are called CLECs, or common keys, and then the operational keys are derived from those. A less trusted SU is one that you don't expect to stay in the domain for a long time, perhaps, or is more subject to compromise, or for various other reasons, they're less trusted. They receive something called a common key, and the distinction here is that it's much easier to change common keys than it is to change root keys. So we've got a methodology that allows us to very, very quickly change a common key, but it's more, it takes more time and resources to change a root key. And we can talk about that more later. We also make a distinction between protected and unprotected groups. A protected group is one that's operating with LLE protection. An unprotected group is one that's not. Now, you can have a protected SU that's authorized to use unprotected groups. It can be a very important use case if most of the time what you want to be is protected, but you need to go into some domain, some area where you need to interoperate with people who are either on legacy radios or operating unprotected for some other reason. So again, we have these distinctions throughout between things that are protected and unprotected, things that are trusted and are less trusted. We'll use in the clear in its usual meaning of it's not protected. I confused everyone. Probably not. Yes, somebody raised their hand, but I can't see who.
Yeah, this is David Havocan with ICOM. I got a question on the on the previous slide, whenever you were talking about the WAC and ID side of things as well. You know, in 90 and 20 something plus years at P25, 95% or more use BEE00. Is there going to be some kind of implementation? I know there's a calculation for it that is published to you know, to calculate your WAC and ID. Is that something that's going to be implemented going forward with this LLE?
Can I take that one, Tom?
Absolutely, I was hoping you would.
Right. So the TIA publishes a document. You don't have to pay for it. It's not part of the P25 standard, but it's a document that describes how you can ensure that your WAC and ID system ID combination is unique throughout the world. And so sometimes that can be based on your call signs that you received from FCC, or it can be based on the manufacturer identity, which is unique, that you bought the equipment for. That's really unaffected by link layer encryption. That's just how trunking systems are organized. We picked up on that for link layer encryption to say if this is a unique identity throughout the world of this system, then that's the LLE domain. Does that help?
Okay, yeah. I would just want to be clear on that going forward.
Yeah. Yeah, it's really, and it's a combination of WACN and system that has to be unique. It's not just the WACN or just the system.
Right.
So
There's thousands of WACNs, and each WACN can have thousands of systems, and each system can have thousands of channels, and blah, blah, blah. So,
yeah. Okay. So, distinction between what happens with protected and unprotected calls. And again, this is pretty basic stuff, but I think it's important. A protected call can be heard by anybody. So I've illustrated this in trunking, but really the same applies to conventional. A protected call can be heard by anybody in that area, in the coverage area, that that has the key. Okay, and we'll refer to the key. It really means the common key, the CLEC. But anybody in the area can listen to it. Anybody who doesn't have that key cannot, right? That's what a protected call is. So unprotected users can make unprotected calls. Okay? Protected users can also make unprotected calls. We'll talk about that in a second. And an unprotected call can be heard by anybody, okay? Just as is true today. Now, obviously, if you have end-to-end encryption running around underneath this, that limits who can hear it. But generally speaking, as in any legacy system, an unprotected call is unprotected. In a case where a protected user wants to place an unprotected call, he's allowed to do that. The infrastructure does not force him to only operate in a protected mode. That's policy of the radio. But when he does that, his voice and his identity is in the clear, right? So and the voice. So when he's operating unprotected, he really is operating unprotected, right? But he's able to interoperate with other people who are unprotected or with other protected users that are able to do so. Okay. Right. Clear? Clear. Right. Another important thing, the site is actually a member of the call here. Okay. So when a transmission from a radio reaches the site, it's decrypted, processed, and then if it's going back out, it's re-encrypted on the way out to the recipients. So it's important to realize that sites have keys in this world. Okay? So it's not like end-to-end encryption where sites are just dumb animals sitting there and passing stuff back and forth. With link layer encryption, the site actually has to be a participant. That's how our identities are hidden while still being able to enforce access permissions and all of the stuff that we have to do in digital systems. Okay. Sort of a distinction in this case is transparent repeaters. They actually repeat transparently. So a transparent repeater is a dumb repeater that sits on a hill and takes P25 in and retransmits it on another channel louder, and they are not part of the link layer encryption cryptonet, if you will. Whole bunch of detail here about CryptoSync. I doubt that anybody cares about it. If you do, there's a very good section in the overview. What CryptoSync is the means by which you guarantee that you have a fresh key stream as you're encrypting whatever you're encrypting. We do have two different ways of doing it. One of them is called implicit, where you derive the CryptoSync from the current time as known by the people involved. And the other one is explicit, where you don't have a common time reference, and so you have to kick up space, if you will, to use up or to do CryptoSync. One of the important things here is that low-speed data, I hadn't mentioned this before, in order to make room in an FDMA traffic channel for the CryptoSync, we had to give something up. There just aren't enough bits. And the thing that we gave up is LLE for low-speed data coincident with link layer encryption. So low-speed data is not encrypted, is not link layer encrypted. It can be included in unprotected transmissions, but it's not available in protected transmissions. Just a detail. Okay. Key derivations. Again, I probably don't want to spend too much time on this, but I think it's an important concept. All of the keys, all of the operational keys in link layer encryption are derived from a single root key. That is to say,
Tom, you have a question.
Yeah, I'm sorry, go ahead.
Arcana question?
Really quickly, can the can the encryption that's used for these radios be integrated with military encryption using the TDMA and FDMA, especially for disk emissions?
Are you asking if the what do we call it,
If
type
the-
1 and 2?
Right.
If the higher grades of encryption are compatible with this.
Correct.
And I believe the answer to that is yes. You know, we use type 3 encryption. We use type 3 encryption, right? For most public safety uses, that's what's involved. But the distinction, there's no difference in the error interface between the real difference between type 1, 2, and 3 is what you use for a key and then how you generate the key stream.
Right.
And so, right, how you negotiate a key. In type 3, it's private keys that are known. In type 1 and 2, it's otherwise, and how you generate the key stream. What goes over the air is the encrypted voice, and so it's already had the key stream applied, and it's transparent. So we make no changes other than to re-encrypt them using LLE. We make no changes to the legacy cryptography, if you will. Okay, so if they're compliant with the P25 standard, then they'll work just fine.
Do you know of any instances where this has been tested? And I say this because San Francisco has over the years struggled to get public safety and their Navy and Army brethren on the same radio system using encryption.
I mean, I don't.
You don't? Okay.
Yeah, we don't. Obviously, LLE doesn't exist yet. So I certainly can't say that. But
Okay.
I can say that if it works over current P25 channels,
Theoretically. Okay.
then it'll work here.
Thank you.
Yep. Okay, so how are the keys derived? You have some key source. This could be, you know, a random number that you make up and type in. It could be whatever it is. And that key source needs to get, by some means, and we have standardized means of doing it, into something called a link encryption facility. So the link layer encryption key facility, or the link encryption facility, is the manager of operational keys within, and key distribution keys within an LLE-based system. You have one root key, and that root key is then distributed to what's used in the fully trusted case. That root key is distributed to those sites, stations, and users who are highly trusted. We'll talk more about why that is later. From that root key, we derive something called a CLEC, a common link encryption key. That common link encryption key is distributed to the less trusted people, less trusted sites, maybe those that are in a more vulnerable area, less trusted radios, maybe visitors. And then finally, from the common key and some site/channel information, we create unique keys for each site and channel. Okay, so every channel in the system has a unique key, but that key, because of this structure of key derivation, that key is derived from a common secret that's shared throughout the system. Okay? What this allows us to do is to have unique key streams for every different site, which is a good thing in a security sense, okay, without having to manage a whole bunch of different wackadoodle keys. Okay? Instead, we're managing either an RLEC or a CLEC, and again, the CLEC is derived from the RLEC in an intelligent way. So you're either handing RLECs to trusted things or CLECs to less trusted things, and then they all derive the operational keys from those RLECs and CLECs that they possess. Clear? Probably not. But it should greatly reduce the key management burden in these systems. What else is important here? CLEX drive to RLEX, less trusted, routine rotation. Oh, this is the important point. There's a bunch of different types of key distribution that we support in these systems. Broadcast key distribution is probably the most important one. There's also a group key distribution method that's important when we do when you're dealing with key compromise and so on. But the general methods that you're using to rotate keys on a regular basis, which again is good security discipline, is this broadcast method. So routine rotation of RLEX is accomplished by broadcast key distribution. Routine rotation of CLEX is also accomplished by broadcast key distribution. And the users that have a CLEC can get the new CLEC, the future CLEC. Users that have the RLEC can get the future RLEC. But because of the way we've constructed this, users that have the RLEC can have the future CLEC as well. Okay, so what this means is that because of that construction, it's very easy to if a less trusted user radio is compromised, it's very easy to very quickly update the trusted users and have them fully secured and operational again, at the cost of having to rekey the less trusted users who might go through an operational quiet period. Okay, it's a structure that we put together to make it easier to quickly recover from a key compromise, and very easy to rotate keys, because most of the time when you rotate the keys, all you're doing is changing this update parameter and then doing broadcast distribution of common keys to those who need it. It's probably confusing, but it's an important aspect of making the key distribution easier, believe it or not. We put the complexity in the software instead of on the user. Okay, policies. I think these are important. We have trust levels we've already talked about. And again, the routine rotation of the operational key for a fully trusted user is essentially seamless. Okay, there's no work involved in doing this. Routine key rotation for a less trusted user does involve broadcast routine, but it's still easy. When an SU leaves or is compromised, fully trusted SUs can be immediately rekeyed, whereas the less trusted ones need to be repivoted first. Okay. It's up to the operator about how to do this, whether they want to accept a period of compromise in exchange for seamless communication, or whether they're willing to smack the less trusted users around for a little while in order to get the fully trusted users back online sooner. That's an operator question. Okay, and we can talk more about routine later. I think it's probably good for now. System policies, there's a bunch of them. These are from the overview, these paragraph numbers. So trust levels, again, we've talked about this already. There's something called a group protection policy. Here's the way this works. For each talk group, the operator establishes, or an agency by proxy, needs to establish a protection policy for that group. Okay? And all it says is whether that group is protected or unprotected. Okay? So what that means is that in a protected group, communications are always protected. Okay? In an unprotected group, communications are not protected. Well, now that I'm thinking of this, this may be slightly wrong. Don't we have unprotected allowed here, or is that users?
For individual, yes, for individual
No,
calls.
that's users. Yeah.
Okay.
That's users. Yeah.
We have another question,
David?
Tom.
Yes, I see one. Yes, sir.
Yes, I was wanting to know on whenever you were talking about the broadcast, let's see, the broadcast key distribution, that term, is that equivalent to OTAR, where you're going to have the ability to update the key?
Yeah,
Okay, that I wanted to be clear on that because I was wondering about that. I had a question about that in LLA as well, which doesn't exist at this time, and I want to make sure that that term means the equivalent of similar to OTAR.
yeah. Let me, and I'll be more, I can say more about that. I have slides to talk more about that later. But the general way of changing keys is over the air. Okay, for trunk systems, I think that's the only way we've provided to do key rotation, to change keys, is over the air. In conventional systems where you don't have infrastructure, we have to use, key loaders to do some of that. In a conventional fixed network, so in a repeater system, basically, you have to do manual key management. In direct mode channels that are not associated with a trunked or a conventional fixed network system, you have to do manual key management. But the entire rest of LLE is all over the air keyed, for sure.
Okay, thank you.
So, may I add something, Tom?
Say it again.
I'd just like to add something to that.
Yeah.
I'm not sure we're talking apples and apples. Tom was describing a broadcast key distribution. So it is sending keys like OTAR does, but the term broadcast means it's going to multiple people. There is no single target. Individual key distribution sends keys to a specific radio. Group key distribution sends keys to a specific group, and broadcast distribution sends it to anyone who's listening. But you have to have the current key to decode the broadcast.
Right.
I hope that helps.
Very good. That's good clarification. Thank you.
Yeah. There's something called the IKSP refresh policy, which is way deeper than I want to go into now, but it is discussed in the overview. The IKSP is a magic thing that helps us to provision keys without having to touch radios. There's a bunch of policies that we expect to be controlled by the agency. Registration policy. This identifies what a protected SU should do when it doesn't have the current key and can't be provisioned by the system. Okay. So basically the decision is go look for other communications resources that are protected in a way that you can handle, or go ahead and operate as an unprotected SU. Because there are situations in which, particularly if a radio has been compromised and effectively kicked off the system, they may try to access the system as a LLE radio, and they'll get denied. And the question that has to be answered is, what do they do then? So that's one policy. Something called a participation policy. This identifies whether a radio can participate in unprotected call, either normally, anonymously, or not at all. So what this allows for is a radio to use an anonymous user ID to participate in a protected call. An unprotected call. There's something called the LLE reception policy. It's a little deep, but what this is an aspect. The radio says to the infrastructure, I'm going to send you something that I want to go to Fred, but only if Fred is also a protected radio. And so what this policy says is either go ahead and send it whether Fred's protected or not, or it says send it only if Fred is a protected radio. And so it helps to preserve that identity hiding across multiple interconnected stations and multiple interconnected systems. There's an individual service forwarding policy, protected only or allow unprotected, which determines whether an individual service by a protected SU can be forwarded only to protected or unprotected SUs. I'm sorry, that's the one I just described. What the LERP says is whether I want the system to forward me such requests. So if Andy's unprotected and Andy wants to send me a status message or a call alert or something. The LERP is what the individual reception policy is my way of telling the system, hey, I don't want you revealing my identity under any circumstances, so don't forward me that request because it's unprotected. Something called a data protection policy, whether you accept or reply to unprotected data service messages or not, and various policies related to conventional direct mode and repeated about how to use, which key to use for domains when you transmit, which key to use when you reply, and what your time tolerance is. Remember, I said that there's some protection for replay embedded in link layer encryption because we use a time coordinate in the crypto sync. The time tolerance is what determines the degree of replay protection, right? I might set the time tolerance to 2 seconds, which means that if the time in the transmission differs by my own idea of what the time is by more than 2 seconds, then I would ignore the transmission. It's that kind of thinking. All right, moving on. Architecture and key derivations. Again, I don't know how much interest people have in this. I'm going to move moderately quickly, probably quicker than I have been, and just stop me if you're more interested than I think you are. So an LLE domain we discussed briefly. The important thing about an LLE domain is that all operational keys within that domain are derived from that common ancestor key, the CLEC or the RLEC, really the RLEC. So the point of it is to minimize the number of keys that have to be provisioned to any particular SU, right? 1. Each trunking site or station, again, has a unique key derived from the RLEC, and it uses unique characteristics of that station to generate its key stream. So we wanted to be absolutely sure that we had unique key streams, because if you don't, then you create a vulnerability. And so the way we constructed the crypto sync and the derived keys for the channels assures that. Right. There are 4 types of keys in the system. The RLEC and the, well, 5 really. There's a bunch of types. The RLEC and this is the root key. It's the primogenitor for all operational and broadcast keys. It has keys associated with it, a key encryption key and a message authentication key that are used in key management, and the CLEC is derived from the RLEC. The CLEC is also an ancestor key, and it's a common ancestor for operational broadcast keys. It also has a key and a key encryption and a message authentication key associated with it. And then from it are derived site keys, the operational keys, the STEC, the STAC. These are the things that are actually used for traffic encryption and for authentication on the P25 channels. There's something called an individual link layer encryption key. This is used entirely for key management. So it has something called an IKSP, which is something that sort of particularizes the ILAP for different domains. The way this works is if in my home domain, I have a particular value of this key security parameter. If I want to visit another domain, instead of sharing the ILAC with that domain, what my operator does is to share a unique IKSP with that domain. Right? So that each domain that I might visit has a unique value of that provides protection for me and them, okay, and doesn't reveal anybody else's ILACs. Again, there are key message authentication and key encryption keys associated with these. And then group keys are, we have group key management operations because they're really necessary in key compromise scenarios to be able to efficiently change the keys for large bodies of users. And so GLECs are a whole nother group of keys. They are have key encryption and message authentication keys associated with them, but they're not a part of the operational key derivations at all. So ILEX and GLEX, individual and group keys, are used entirely for key distribution. Okay. RLEX are used for key distribution, and they're the ancestor of CLEX. CLEX are used for key distribution, and they're the ancestor of the real operational keys that are different for every site. Okay. I talked about this. I guess it's just saying it again. You have broadcast key distribution. Andy said, the purpose of broadcast key distribution is to deliver a key to all radios that either have the current RLEC or have the current CLEC. So we use broadcast key distribution protected with an RLEC to send, with the RCAC rather, the derived keys from an RLEC, to provision the future key for fully trusted users. We use broadcast key distribution where the key is protected with a CLEC to provision the future key for less trusted users. Okay. The RLEC people could get the CLEC if they wanted to, because they can derive it. It's not important because they already have the key. The CLEC people can't get the RLEC. Okay. And nobody who doesn't have either can get either. Group key distribution is delivering the key to a subset of radios, so that the link encryption facility manages, constructs and manages groups, and these are different than voice groups, LLE groups, through means that we're not going to go into, and they can be used to provision future RLEX and CLEX. So if I want to, and this is important to keep compromise, because you presume that somebody is a member of a group. Okay, you can use group distribution to send the keys to every other group other than the one he's a member of, right? And then you have to use individual or some other method to provide the keys to the people in his group that aren't him. So the compromised unit can be excluded by using a combination of group key distribution and individual key distribution. Individual key distribution delivers a key to a specific radio. It's used initially to provide a key to a radio that doesn't have one. We'll talk about that. And it's used to catch stragglers when group and broadcast key distribution doesn't manage to hit everybody. And finally, KFD and OTAR, same. It's really used for individual ILEC enablement and for key provisioning systems that don't have trunking or conventional fixed network stations. So the only place where we're using key fill and OTAR is to provide an individual key initially to the radios, and then in those systems where there's no infrastructure to support it. Let's see. How are we doing on time? Almost an hour in. Trying to decide if I want to go through this. So conventional, so as I kind of suggested, this individual key is important both in key management and in initial enablement. So the distribution of this initial key in a conventional system, right, is by the usual means that we distribute keys. It's by key fill, it's by IKRI to a KMS that can do OTAR to the radio. Either way, it's getting the key to that radio. What's the second one? Oh, it's another use case. So that key source can be an external thing that uses IKI or key fill to provide the key, or it can go in the other direction. That is to say, the LEF can be the source of the key to the radio, or an agency can be a source of the key to the LEF. Either way, what's important is that the link encryption facility and the radio share a common key. Okay? And that's the ILEC, and it's unique per radio. In trunk systems, it's really the same. The only difference in trunk systems is that we have this ability to share across domains over the IKI, and in particular to share the IKSP, the key security parameter that allows a radio from one domain to visit another one and operate with protection. Okay. So you've gone out and you've provisioned all your sites with your keys, and you've given all your radios their ILEX. And you flip the switch and link layer encryption is now operating. How does the radio get the key that it needs to be able to do its job? This is what this is about, and this is kind of the black magic. A radio that wants to operate in LLE, okay, sees from the broadcast messaging, new broadcast messaging, what the current key ID is for the system, what a future key ID is, if there is one, okay, and what the capability is of the system. So from the broadcast messaging, it sees that, oh, this is a link layer encryption protected system, and it can see what the name of the key is for that system within that domain, okay, the key ID for that thing. If he has the current key, he just registers essentially normally, okay? He registers except protected. He uses the same registration messages, gets the same kind of registration responses, optional link layer authentication, then he affiliates and gets the responses to that. The difference is that there's some additional information added to these messages for link layer encryption. In the affiliation, for example, okay, when you affiliate, you say, hey, I'm interested in this group. And the station comes back and says, okay, here's the name of, here's the local name of that group. It also now will include the group protection policy. So it'll say to the radio, you're a member of that group and you have to operate protected with that group, or you have to operate unprotected with that group. Okay? So we're distributing the policy via the messaging rather than having to program it. Likewise, when it pushes, when the radio affiliates, it's also giving the station some information. It's saying, hey, I have the future key or I don't. If the radio doesn't have the future key, that allows the system to start broadcasting that key so we can get it. It says, here's my individual reception policy. Here's whether I want you to send me unprotected messages or not. And it says, not anything I'm going to go into, provides a group key inventory summary, which is a way of managing group keys, the group link layer encryption keys. So it's registering. It says, here I am. I can do LLE. The station comes back and says, thank you very much. And it also gives an indication whether it can do key distribution, if it needs individual key distribution to that user if it needs to. Okay. So that's regular registration. Again, this message flow is essentially the same as regular as unprotected legacy P25, except it has a few more bits of information in it to make our lives easier. An unprotected radio that comes in. So if I don't have the current key, what happens? Well, this is what happens. Again, I've learned that I don't have the current key, okay? But I'm LLE capable and I want to operate with link layer encryption here. What do? Well, you register unencrypted once, okay, with a magic bit that says, hey, I'm LLE capable. And the station sees that he's LLE capable, but he's not operating with LLE. Therefore, he must need the key. Station responds. He says, hey, okay, love to have you here. I have your ILEC. I'm going to provision you with a key. or don't want you here, I don't have, at all, or I have your, or I don't have your ILEC, so I can't provision you with a key. If the station doesn't have the ILEC, then the radio has to make a decision whether to operate unprotected or go look somewhere else. Okay, it's one of those policies I talked about. If the station does have the ILEC, well then link layer authentication can happen as usual. Okay? And then the station distributes using this individual key distribution method. It securely distributes either an RLEC or CLEC, whichever it prefers, to that radio. Okay. So and then the rest of it proceeds secured. So you have these few exchanges that happen once, that are unprotected, so that the user's identity is revealed for this short period of time, and then he operates normally with LLE. Okay. By giving up that little bit of protection, what we're doing is saving massive amounts of administrative burden, right? Because I can enable a radio by simply by having a shared ILEC, right, and turning it on. I don't have to manage that either CLEC or RLEC or whatever remotely. Right? Likewise, if the radio happened to be in a garage when I changed keys and he doesn't have the keys, he can revert to this unprotected method once and get the new key if he's authorized to have it. This is a very important means that we've created to try to minimize the amount of manual key loading and touching of radios that people have to do. Clear? Uninteresting? On one?
So I've
Yeah.
got a question. This is John O'Connor in
Yep.
Memphis. So if the initial affiliation is in the clear with the unit ID,
Yep.
Can someone who's listening to the control channel, the link layer, use that information later to figure out who that unit is talking, even though it's encrypted?
No, it doesn't help them later, because once that guy's been provisioned with the key, he's operating protected, and he's got good 256-bit data protecting him. So if I was somebody moving into an area and I was really paranoid about wanting to protect my identity, okay, what I would do is I'd probably set up a room somewhere that had a local site or something, and register in a low power mode or something in some way that protected the RF, and then I could go out and do my business. Your identity is revealed once briefly, okay, during this first registration, but then it's never revealed again, okay, and nobody can derive it again.
Just one more thing to add to that. John. If you do not have the link layer encryption keys, you have to send in the registration request in the clear. And so someone could see that. But the next thing that's going to happen is you're going to receive the LLE keys, and everything after that will be protected. So whoever saw you request registration never saw you get accepted and will never see you again.
Well, they'll see you again because the next transmission will be a packet with an encrypted unit ID. And if they listen to enough of those over time, they might be able to.
Well, I think you're talking about associating a clear request with an encrypted response. And so, that does allow supercomputers to attempt to break the encryption. But there's going to be so many other encrypted messages going out. Which ones to associate with your clear request is going to be very, very difficult.
Yeah, I mean, I think what you're saying is
all right,
that
thank you.
You're suggesting that somehow this affiliation leaks information. that allows him, that helps him do a brute force attack later on. And I'm not sure I agree with that. You know, again, the crypto.
It's a needle in a haystack.
Yeah, exactly. Yeah. Initial key distribution, intersystem roaming and conventional. Okay, what am I talking about here? Initial key distribution extensions for system roaming. Oh, okay. So the same thing happens if I want to move to a different system. So if I have a, this is this IKSP stuff that I murmured about before. We've basically extended this method so that you can share really a public parameter with you share a parameter with a adjacent system, and they can provision their key to your radio to operate in that system. I don't want to go into the details of this because I think it gets a little bit grumpy. But the result is that once the IKSP is shared, the process is to provision a roaming SU, a radio that roams from one LLE domain to a different one, are identical to those to provision the SU in its home world, and don't involve any other sharing of information, right? So that the operator of the visited system doesn't have to share a key with anybody in the home system. The operator of the visited system doesn't have to touch the radio. All he has to do is, once he's received this magic parameter, he can provide that radio with the key to operate his system without impacting anybody else. In conventional, you know, again, the conventional world, there's a lot of this stuff that isn't, some of this stuff isn't possible. But CFN stations, there's no registration, but we provide a very similar mechanism for individual key provisioning and, for operational key provisioning in a conventional system. Basically, we've created something that says, hey, I'm here and I need the key. In trunking, we included that in the registration message because conventional doesn't have registration. We provided a message to do it, and the same kind of procedures happen with automatically distributing the key. Okay. I can go, Andy, what do you think? Should I continue through the key rotation and key distribution stuff?
Well, in my opinion, that's pretty deep, and I'm not sure everyone has gone this deep yet.
Yeah, I agree. I think the thing that's important beyond this is that we have created methods that we think will work pretty efficiently for distributing. So I've talked about the method for onboarding. We've created methods that should work very, very efficiently for the routine rotation of keys, which is just good security hygiene to occasionally change a key. We've created methods that are, very efficient for routine rotation, pretty efficient for compromise, and really hidden for initial provisioning. So we've got a collection of key management techniques that were designed to efficiently make use of the air interface and not provide a huge administrative burden. Somebody's asking a question. Chris, is that you?
Yes, it's me. Good to hear your voice again, Tom. And Andy, always enjoy these presentations. I was going to wait till you were done presenting the slide to ask the question, but since you stopped, I'll ask it now. When it comes to key rotation, it's not too hard to imagine where I may have a subscriber that is on my home system, and I may be roaming on to 5 or 6 different trunk systems and possibly, 2 or 3 different conventional systems. All of them may have different rotational periods for those keys. Yep. All of them may be using different interfaces to swap out those keys. Inside of the subscriber unit, how deep is this going to go to specify the level of access or the process to update a specific CLEC or ILEC or anything
Right.
else that may be needed for this? You know, we're going to have a lot of granularity with this, or is it going to be something overarching that has to dictate how everything works?
Oh, it's going to be perfect. It's going to be awesome. Okay, so look, here's what you have to keep track of. There is one ILEC that is managed by the owner of the radio. Okay. And
Per system.
No, there's one ILEC that's managed. Yeah, I guess. Yes, if the radio is programmed for different systems and has a different SUID in different systems, then you would expect to have an ILEC for each of those. Yes. Is that what you meant, Andy?
That's what I meant for manual roaming. You can manually roam between systems, between trunking and conventional. And when you do manual roaming, you have a unique personality for each of those systems. When you do auto roaming, the connected system will go back to your home and get the IKSP, which is a derivative of your ILEC. Now, I think, Chris, the important point to understand is that, yes, you probably want to operate on different systems, and you may or may not be connected between those systems. And so, as Tom explained, the first thing you do when you select some new system is you say, is it LLE capable, and do I have the keys? And if you don't have the keys, first thing you will do is get the keys. And so once you have the key for each system or each conventional channel or domain, all that rotation stuff is handled privately by that system.
That sounds really efficient and simple. I appreciate that. That's a good way to do it.
I'll remember you said simple.
Yeah. Well, again, the distinction here is between automatic and manual roaming. If you're manual roaming, what you have in essence is multiple radios, right, from a personality perspective. And so the key follows that personality. So you would have individual ILECs and then the right keys for each system. But the only keys that you have for any particular system are the RLEC or CLEC, so one of those, and then whatever group keys you need to be managed within that system. So it's a small set of keys per system for an SUID. It's a small set of keys. And if I'm doing automatic roaming, it's even smaller because I can get provisioned in each one.
We have another question, Raven.
Yep.
Go ahead.
Yes, good morning. I'm Sergeant Carr with the DC Guard. So I know I may be a little late in asking my question, but as far as with the keys and things of that nature, so we do not have our own organic system. Like we're putting our radios are on other people's systems. So if the keys get changed, do we physically have to go to them and get like our key loader loaded or get say again?
No, that's the beauty of it. So this ILEC really, once you have one ILEC for each of those, so in manual roaming case, I think that's the most common one. Once you have an ILEC for each of those systems, if you've been away and come back, your radio will get re-provisioned with the new key.
So it automatically happens as soon as the radio comes up on the network.
Exactly.
Perfect.
Exactly. Yeah. Yeah.
Hey, it's Justin. I have one question.
Yes.
If y'all said something about the ID that got me a little nervous. So if we happen to have multiple systems in the radio, but it had this same unique ID, is that going to be a problem, or would that? So like here in Texas, we have a statewide ID plan and use the same ID on multiple different systems.
Depends on what you mean by an ID. I mean a fully qualified ID, WACN system and user ID.
Okay. All right.
If you're distinct at the WACN system level, you're fine.
Okay. Perfect. Thank you.
If you're not distinct at the WACN system level, you should be.
You answered it. Thank you.
Okay.
There was
Anything
a
else?
request to go. There was a request to go to slide 31.
31. Where's 31? I can't see slide numbers here. Okay, 31. There it is. Okay, group key distribution. Yes. That's the one.
Yeah, David, you had a question?
No, what I'm trying to do is I don't know if we're going to be distributed this right here, but I'm just wanting to make sure that I'm, capturing what these slides are. That's all.
Yeah, these are particularly the ones at the end here I haven't touched. But we'll send this out again. I'll get it to Jimmy and he can send it out. This revised version that has that little bit extra material at the front. But this was in the this slide and all the ones down here in the later part of this are the same material that was in the previous presentation.
Thank you.
Yeah.
Can I grab the last 10 minutes, Tom?
Absolutely. As much as you like.
All right. So
Hold on. Let me see if I can get out of here. Stop presenting. There we go.
all right. So just I don't know. I don't have enough time to go through what I was going to go through. This is the third one of these user presentations that Tom and I
Andy,
have
the
done.
time runs till 3 o'clock. You got a little over half an hour.
Okay. I guess I was looking at the wrong meeting notice. Well, thank you then. So, that being said, what we're trying to do with these sessions is to help the user community understand a very complex subject that's still being designed. And it's important that when you have the time, you pay attention to what we're designing before the paint dries. And so if you see something you don't like, we still have time to change it before the paint dries. Or if you have a question, well, that's not how I want to use it. Here's how I want to use it. Is that going to work? I mean, all that stuff is the kind of things we're trying to get from the user community. And so we'll have another one of these sessions in Savannah, I believe on October 25th. There'll be GoToMeeting access to that, so anyone can join. But again, the point is to help you get a basic level of knowledge so that you can participate time permitting and help us watch out for things you don't like. Now, that being said, one of the things I tried to do, and I will attempt to share since I have time. I created this document with Tom's help and with Tim's help that we called the Roadmap to the Link Layer Encryption Overview Table of Contents. Link Layer Encryption Overview is the first thing you should read if you're interested in how link layer encryption is going to work. And so what I tried to do in this document, or we tried to do, is identify sections with their titles that are important or of interest. And so, the scope section, you can read that. You can read the abbreviations. You can read the definitions. In section 2, which is titled Overview, there's a high-level overview that provides information on what is link layer encryption versus link layer authentication and versus end-to-end encryption, and what kind of error interfaces does link layer encryption apply to. General information. 2.2 is link layer encryption keys, the types of keys. The bottom line here is the key that you use to encrypt over the air is called a System Traffic Encryption Key, STEC. It has a partner, STAC, which is a System Traffic Authentication Key. So the different types of keys, root keys, common keys, operational keys, gets a little confusing. Just know that the STEC is the one you use to protect. There's a section 2.3 describing how we do the encryption synchronization. Section 2.4 is affected interfaces. I'm just going to walk through this roadmap to the table of contents. I don't want to waste your time by reading the sections that I'm asking you to read. in Savannah. I hope that as many people as possible can read these sections. I hope this guide to what's important and what's not important will help you make the best use of your time. But that's what this document is all about. And so I will pause to see if there's any questions on this document or if you want me to go to any of these sections. But what I will not have time to do, I don't think today, or what I prepared to do if we have time, let me say it that way, is I created another script for myself. I'm happy to distribute it if it's useful, but the script basically describes how would a link layer encryption radio find and register on a trunking system as compared to a non-LLE radio. How would it do authentication, affiliation? How would it do authentication? How does it make a group call? How does it make an individual call? How does it receive an individual call? How does it move around within a system between the different sites? And how does it move between systems? So let me pause just to see, what would you like me to talk about? I can go through that roadmap. I can go through these descriptions of the basic steps of how a radio comes on a system, gets the keys, and starts to use the system. What would you like me to talk about?
Actually, I just wanted to know, what do we need to do in order to be able to request a copy of it so we would be able to read on our own?
Well, Mr. Downs has already distributed the presentation and this roadmap to the table of contents. So those are certainly available on request from Jim Downs if you did not get them. The presentation Tom gave today is a slight modification of previous presentation already available. But again, Tom will make that available to Mr. Downs and you can get whatever you want from him.
Thank you very much.
So what do you think? Would it be useful for me to walk through this table of contents? I mean, I intended it to be a guideline for, you know, what should you go read? But I don't really want to waste your time or mine time reading it for you. Would it be interesting to walk through this other document that has not yet been distributed about how does a radio register? How does a radio affiliate? How does a radio get the keys and start making calls? What would you like to spend time on? Anybody?
So
Andy,
I would go with
since
the latter.
nobody seems to be speaking up, I think the second document that you mentioned, you know, that nobody's seen yet, you know, if you could maybe talk through that a little bit, just for familiarization, and then we can distribute that document as well.
I think
April
the other thing
has her hand up.
Yep, I saw that Justin was about to ask a question. I think we've got another caller with a 508 area code looking to ask a question as well.
Well, the 508 is me, Tom. Just doesn't have my name on it.
Justin, what do you think?
No,
Yeah, Justin.
I was just going to suggest that the lateral is better because I think
right.
that would be a much better place to go. So, yeah.
All right.
I agree.
So
And I think, Andy, if I can just suggest here, I think that the Savannah session, I think we should focus on that. Right? Let's
focus on,
spend
what do you mean by that?
taking the document that you're about to,
Okay.
the script that you're
Yeah,
about
I'll
to
walk
go
you through it today and I will
Yeah,
clean
and
it
then-
up
and let's
and make it
formalize it a little bit.
distributable.
Yeah.
And I would
Chuck-
like your help cleaning
Chuck
it.
Rawlings, you had a question, your hand up?
Yeah, I was just going to say I'd like to hear about this latter document here because I'm really interested to hear, you know, how does a radio that is not on a specific trunk system be able to get on that trunk system and allow it to make, you know, calls into groups and group calls and participate when it's not even part of that system. I mean, that's the whole reason why you manage the trunk system and you set up your fleet maps is to assign those capabilities and those policies, you know, who can do what, who's got what capabilities, who can do what lateral movements or whatever within the radio system. And you're allowing as far as I'm concerned, a rogue radio come in from the outside and it'd be allowed to do that. So
No.
that
Everything
explains.
else-
I think
yeah,
some of this
everything
will
else is
help you
above.
understand,
Okay.
but I think you need to first understand in trunking. A trunking radio will find a control channel and will send in a registration request unprotected. And
Yes.
the system operator has a database that says, you know, do I accept radios that I do not recognize? Do I accept everybody, or do I have a white list of here's who you accept and here's who you don't accept? So that's already in place.
Okay.
I think that's part of your answer.
Yeah.
Now, when you have roaming between systems that are connected with an ISSI, the radio coming onto your system will give you his home identity when he sends in that registration request. And you will send messages across the ISSI to his home. Say, this guy wants on my system. What am I supposed to do with him? The decision on whether to allow him on or not is ultimately yours. But the system that he came from will help you figure out who he is and whether he's supposed to be there or not. And that's an oversimplification.
Okay.
Andy, it sounds like that most of the people that have responded are looking for the second document you're talking about that we haven't seen yet. So let's spend the rest of the time on that, and then we'll make sure we get all the documents available
Sure.
for distribution of whoever asked for them.
All right. Well, I'm showing it on my screen. I hope you can see it. Can anyone confirm? You see?
Yes, we can
a
see
Word
it.
doc? Okay. And so I just put this, not knowing what to expect from today's webinar. I just put this together in a couple hours yesterday. So I will clean it up, and I will get input from Tom and from Tim to clean it up, and it will be available before Savannah. And I think this is a good subject for Savannah, unless somebody else has other ideas. But anyway. I'm starting with trunking because trunking is more complicated to design. And whenever we design a trunking system, we then step back and say, okay, how much of that will work in conventional? And let's reuse absolutely everything we possibly can. Now, conventional does not have a control channel. Conventional does not have registration, does not have affiliation, does not have access control, does not have authentication. So conventional systems are technically primitive compared to trunking. But the reason I'm starting with trunking is, look, if you understand this, or if you can follow through this, then we can say, here's what does and doesn't apply, or here's how it would work in conventional. And again, we try and reuse as much as possible. So how does a LLE radio register as compared to a non-LLE radio? An unregistered non-LLE radio just finds a control channel and sends in the registration request. And now it's up to the system to authenticate them if they want, or authorize them if they want, or do whatever they want. An unregistered link layer encryption radio will find the control channel, but it has to briefly monitor to see if link layer encryption is supported on the system. And if it is, it needs to briefly monitor and see what the current keys are, so it can determine whether it's capable of sending in a protected registration request or whether it must send in a clear registration request. So if the radio has the LL key, which means it's probably been here before, maybe yesterday, maybe last week, it registers protected. If it doesn't, it registers unprotected. The registration request from an LLE radio contains a new bit informing the infrastructure, which I call the fixed network equipment, or FNE, that the radio has LLE capability. So the infrastructure interprets a protected registration as, I see you're an LLE radio, you came in protected, you must already have the keys, let's proceed. If I come in that says I am LLE, but I sent in my request clear, the infrastructure says you need the keys and we're going to do that first before anything else happens. With one caveat, if you have authentication will be done before proceeding to that individual link layer encryption key distribution. Once the key distribution is made, you'll get a protected registration accept, and trunking radio software then immediately goes to affiliate to your selected talk group. And now that you have the keys, you'll send that affiliation in protected. So that affiliation request is protected. A non-LLE radio just sends the request and the FNE will reply indicating an accept or deny. An accept response includes the working group ID, which is a shortcut ID for the group that's used on the control channel, and an announcement group ID. The affiliation request from the LLE radio is sent with protection and includes new information. It's going to tell the infrastructure, okay, I obviously have the current RLEC or CLEC because I'm coming in protected, but I may not have the future, and I will need that before you rotate. And so it indicates whether it has the future or not. If not, the FNE will come back to that radio at a convenient time and distribute the future keys. The affiliation request also includes this link layer encryption individual reception policy that Tom mentioned. This tells the FNE whether this radio will accept individual calls from unprotected radios. Trunking infrastructure is smart enough to keep track of who's got protection, who doesn't, and use this piece of policy to determine whether, if you told me that you don't want to talk to legacy radios, then if a legacy radio tries to call you, I'm going to deny him. That's what that policy is for. It also will provide a group key inventory. I don't want to spend much time on group key. It's a key distribution method that's efficient for recovery scenarios or recovery from compromise, but that's another piece of information that may be provided in the affiliation request. And so this is we've modified the affiliation request that only LLE radios and only LLE infrastructures will understand. As Tom mentioned, an LLE capable radio is allowed to affiliate to an unprotected group. That's based on the policy in the radio. And an unprotected affiliation request to the infrastructure for a protected group will be denied. The affiliation response from the FNE also includes some new information. When you affiliate, you send in the full group identity, and the response will tell you, I accept your affiliation. Now I'll keep track of you so I can route audio to you. But I'm going to give you this shortcut working unit ID. This is where the radio learns whether the group is protected or not. If the, let's see, catching up on my notes. So if the LLE capable radio, he doesn't know whether the group's protected or not. He just sends in the request and he waits to find out. So if he's sending in an affiliation request to an unprotected group, in the response, he's going to say, okay, this group is unprotected. Now I have another policy. Do I actually want to allow my user to operate in an unprotected group or not? If the answer is no, then I go find another group, somehow notify the user to change talk groups. So now you have the keys. Now you have told the infrastructure what group you're in. He's told you whether that group is protected or not. So how do I make a group call? Well, in trunking, you send a request to the working group identity in protected mode saying, I want to make a call. The infrastructure knows where all the members are. And so he sends a protected response to all the sites that have group members, and all the group members participate in the call. If the group members receive an unprotected call assignment and they've been told this group is supposed to be protected, something's wrong and you ignore that. So anyway, that's how you request and it is assigned an encrypted or LLE encrypted group call. Individual calls are a little more tricky because the radio that initiates the call does not know the LLE capability of the target. And so that initiator might be an LLE radio. And so he will send in a new piece of information in the individual call request that says, here's my target ID. I don't know if he's protected or not. But if he's not, I may not want you to process this call. So there's this PP or protection policy bit. If the FNE determines the target is not LLE capable, and the policy in the request is protected only, the call will not be set up. If the F&E determines the target is not LLE capable and the policy in the request is allow unprotected, the call gets set up in the clear. So call assignments for unprotected calls are sent unprotected, even though one of the members might have LLE capability. And the call assignments for protected calls are sent protected. So, you know, if the F&E determines, hey, your target is protected, you're protected, I'm setting it up protected, and the call assignment is protected, and away you go with the conversation. Now, an LLE radio receiving an individual call, the person calling the LLE radio doesn't know whether he's LLE or not. And so here's where that other policy, the LIRP policy, comes in. If the infrastructure gets a request to call me and I'm protected, but the request comes from Tom, who is not protected, the F&E checks my policy to determine whether the call should be granted or not. If I told him my policy is do not hook me up with unprotected radios, the call's denied. If the policy is, yeah, go ahead and allow that because it's more important to communicate than to be protected, then the call will be clear. Feel free to jump in anytime, but I'm just going to keep whipping along here. So how does a Layer Encryption radio do intra-system roaming as compared to a non-LLE radio? Intra-system roaming is moving around between sites within the system. So the non-LLE radio, when he decides it's time to go to a new site and finds the control channel for that new site, he sends in a location registration request. He uses his working unit ID, that's the shortcut individual ID I mentioned, and he indicates the talk group he's using. So the site sends an accept or deny. This location registration request is how the infrastructure keeps track of which individuals are at which sites in case I need to call them, and which sites have members of particular groups because I need to route them audio whenever that group is assigned. So currently, there's just still some discussion here, and I've made some notes on that. The LLE capable radios will currently assume that since I've already registered on this LLE system, I'm going to assume that all the sites I go to within the system are LLE capable. That's still under discussion, but that's the way we currently have it. So the LLE capable radio will include new information in that registration request. He's going to give that new site, here's my individual reception policy, and here's my future key status. So now the site is smart enough to handle the individual calls and determine if he needs a future key in anticipation of a rotation. The F&E response to the LLE capable radio also includes indication of, hey, you told me you were on this talk group. I'm just going to remind you this talk group is protected, and I'm going to tell you whether I'm capable of doing key management or not. And so, you know, if I'm not capable of doing key management and there's a key rotation, you got a problem and you need to go somewhere else in the system. So intra-system roaming to and from isolated sites in an LLE system is another topic that is still under discussion. The concern there is, what if I roam to a site that's isolated because that's the only one I can see in the system? And what if he's using an old key that I don't have? Or what if I come from an isolated site and I'm using an old key that the rest of the system doesn't have? That's all still under discussion, but it will be addressed. So the next point here is inter-system roaming, or roaming between systems, and I'm assuming auto roaming. So inter-system auto roaming, as I mentioned, the roaming radio registers on the foreign system using its home full unit ID. The ISI interactions between the home system and the visited or serving system then coordinate completion of the registration. That's just normal auto roaming ISSI operation. The LLE radio does basically the same things he does when he found his home system. Are you LLE capable? Do I have your key? I'm going to send in a registration request that may or may not be protected, and that will tell you whether I have your key or not. And if I don't have your key, then you need to talk to my home system, get the credentials to perform an individual key distribution, and set me up for operation on your system. That's basically the end of this brief. How do I get on? How do I make calls? How do I move around for trunking? So let me pause here. And then I have a very
We have
short
a
notes on
Chris,
conventional.
Chris Myers, you have a question?
Go ahead.
Yes, Andy, for the intra-system roaming part, can you give us a little bit more background on the current status of the assumption that all sites will have LLE activated for a subscriber that has that feature enabled, programmed in, equipped, and set up? Just the reason I ask is because I can imagine a scenario where you've got some very big systems, 150 sites plus, where as LLE is deployed, you may have a mixed operating environment where some sites have been fully updated to it and some sites have not been updated to that yet. So I'm just kind of curious as to where that sits as of today, as far as some of the discussion topics.
Mr. Evans recognized that point also. Very useful user input. The reason us engineers decided everybody should be yes or everybody should be no is because that makes call processing much easier. Now, it doesn't have to be that way, and we will be exploring ways to get around that when we're in Savannah. I'm working on that presentation also. But the point is, if I come on to an LLE site and I affiliate to a group and I've given you all my individual call policy information, I'm good to go. And now I go to another site that's not LLE capable. He has no idea how to handle me. And he has no idea what these policy bits, all this new information that I mentioned in these different registration requests and response and affiliation requests and response and call requests and response. A non-LLE site will not understand that signaling. And so that radio is going to be confused. Alternatively, if a radio comes onto the system, he's looking for LLE, it doesn't have, the site he came on to doesn't have it, he's got to register as if he is not LLE capable. And now he moves to a site in the system that is LLE capable. What does he do to, okay, that was those sites, this is this site. So essentially what we're still designing is how radios that are LLE capable can move within a system to sites that either are not or come from sites that are not and go to sites that are. It really affects the call processing because whether you have centralized or distributed call processing control, you know, in trunking, you're basically keeping track of where every stinking radio is. And now you've got this service that may or may not work, and you may or may not get the information you need to figure out how to handle these calls. That's the reason we started out with all or nothing. I don't think that's a hard requirement. We are working on that.
Yeah,
Thank you.
I would point out one additional thing.
Yeah.
Which is, at least I believe, that there's nothing that we've designed in this that I think should drive people to needing to do a hardware upgrade in order to go to LLE. Everything is at the MAC layer. It's it's stuff that there's not a lot of weird stuff in here that would require, like the difference between TDMA and FDMA, for example.
Right.
Might require changes in transceiver design and so on.
Right.
So there's nothing here that suggests this anything but a software upgrade. So if it can, in that scenario, you can blow the new software out to everybody and it can operate in legacy mode. And then when you're ready, right, flip the switch. So I don't think I hope it's not as big a problem as people might think it is.
So I
because we
agree
think
with
it's just a software thing.
I agree with everything Tom said, but software is usually not free. And sometimes you need new hardware to support your new software because it's much larger. And so I think, you know, what Chris and Justin have already, at least the way I interpreted it, is you're not giving this stuff away. And I'm not ready to pay for every radio, every site. Will it still work? And the answer is, well, we didn't really think of that. That makes it harder, but we can do that.
Yeah. We got another question. Mr. Grazzo, you have a question?
I do. Hey, Andy, longtime listener, first time caller. I had two questions. You were talking about the policies. And one, I'm just wondering if there's a way on an individual radio, I almost hate to suggest empowering our end users too much, but if there was a way to do like a selectable policy that the message comes back and says, hey, this is an unprotected individual call, would there be a way for that subscriber unit to then make that decision on an individual basis? And then I've got one other one. I'll go ahead and ask it, and then I'll mute myself again. Do you have any indication as to if the policy is going to be different for an emergency call? Again, that may actually introduce a variable and potentially a malicious vector for somebody to attempt a malicious call where it overrides some of these policies. But has the emergency call been addressed, and are those policies different, or can they be set different?
Right. So let me start with that one. Go ahead, Tom.
Can I pop this?
Sure.
I think the advantage of having most of those protection policies as part of the radio is that the radio can, the manufacturers can put in any collection of policies that are as complex as they would like, right? So if you want to have a different policy for unprotected emergency calls versus, versus unprotected regular group calls, that's certainly a feature that people can implement. So by putting most of those important agency policies in the radio, I think we provide for that. The one, and this is an interesting input, I guess we need to, because the group protection policy is provisioned by the system to the radio. And an emergency call, how that interacts with emergency call, we've always assumed that it stays with whatever policy it had. I can certainly imagine having a group protection policy that says, that's provisioned by the system to the radio, that says it has to be protected unless you're in an emergency. Although I can't really imagine how that would be helpful, because the people who are, and maybe Andy, you have an answer to this, the people who are members of that group that are going to hear it in normal operation have to be protected.
Yeah,
So
I
Andy,
think let's start with the emergency question from Red first. So you can have emergency group calls and you can have emergency individual calls. Let's start with the group call. So for an emergency group call, you're basically sending in a call request on that group with your emergency bit set. In order to send that request, you had to have affiliated to that group. Even if your radio says when you hit the button, automatically change talk groups, you're still going to affiliate. So the system is going to tell you this is a protected group. And so, gee, I'm not LLE capable. I got this auto revert thing. When I push the button, it jumps over to this other talk group. And I don't know anything about LLE protection, but I attempt to affiliate to this group so that I can request the emergency call. The infrastructure is going to say, no, that's a protected group. And so, gee, that's a problem for the user, I would think. It's traced to a bad configuration, but it could still happen. And so what would the system, what could the system do? Well, the system could be smart enough that, hey, there's an emergency affiliation here. I need to change my policy for this group, but that opens the door to all sorts of attacks. And just like this moving around between protected and unprotected sites, if you're going to allow a group to operate protected sometimes or somewhere, but not everywhere and not always, that's a security vulnerability. And yeah, you get to decide whether you want to be vulnerable and under what conditions, but that's really a bad idea if you're concerned about security. So no, I don't think we have considered yet, but could be considered. What happens if a request or an affiliation to a protected group comes in with the emergency bit set, and that radio is not capable of LLE? We have not considered that yet. It can be considered. Now, your other question about individual calls and setting letting the operator of the radio set the policy. Well, there's two types of individual calls. One says it's called availability check, where I send in the request and the infrastructure sends that request to the target and says, hey, Red wants to talk to you. Are you okay with that? In that type of a call, it's possible to send an indication that says Red wants to talk to you, and by the way, Red's not protected, and use that information to make your decision whether you want me to set up this call with Red or not. The other type of individual call is simply, I'm going to request it, the infrastructure is going to assign it, and maybe I'm there and maybe I'm not. And so in that kind of situation, there really isn't an opportunity to let the radio decide. The infrastructure has to make the decision because there's no availability check. So these are good scenarios. This is the kind of stuff we want to hear from users. I don't know if Tom's making notes. I'll make some notes about these questions that came up so we can discuss them in the encryption task group at some point in time. But first of all, did I answer your question? Thank you for the questions. Did I answer them?
Yes, indeed. And I
you.
think while taking notes, I'm just trying to pull up CPS because sometimes I get lost in the actual terminology. I was trying to remember in the scenario for an emergency call, there is a setting in programming to essentially allow within the infrastructure to allow an emergency call at a site where it normally is not allowed. And I think
Correct.
in that type of a setting, it might be interesting that you may have a subscriber unit that does not have LLE and was already denied by the FNE for a talk group not authorized at that site. And then it essentially tries again with an emergency call and sort of, how does it handle
Right.
that? So it may have already been denied registration and now it's coming back with an emergency call, which the
Well,
talk
so
group may be authorized
there's
that
really
way.
two
So
different things. There's really two different things going on there. And another interesting note to make for me, that's a site authorization. So the standards really don't describe it, but they certainly allow manufacturers to have authorizations at the site level. So is Red allowed to use my site? Or is the talk group Red has selected allowed to use my site? And what you just mentioned was, well, it depends on whether Red's in emergency or not. And so that's basically a site access authorization based on emergency status. It's a little bit different, although it's related to, do I want to downgrade this protected group to non-protected because of an emergency situation? So they both come into play, and I'll make note of both of them. But I don't think that site authorization is really quite as tricky as the group is protected. You got an emergency. You don't have anywhere else to go. Should I downgrade?
awesome. Thanks, Andy.
So now I believe we really are almost out of time, and I just only have, a few paragraphs on conventional, because I ran out of time yesterday, and also because, just pointing out the differences in conventional. There's really three different kinds of conventional configurations: radio to radio direct, radio to radio via a transparent repeater, which means no wireline connection, no signal manipulation, transmit whatever you receive, but transmit it at a higher power. And a quick note here, because the question came in privately, vehicular repeaters, that's not what I'm talking about. That's a whole nother animal for another day. And then the third conventional configuration is what Tom called a conventional fixed network. So now I have a station that's connected to a console, or it may be connected to other stations, and it may or may not repeat what it receives. It may only be used to talk to the dispatcher or to talk to other channels. But a conventional fixed network station will modify the LLE signal. That's the important point to note there, at least from my opinion. And so LLE operation on a conventional channel, any one of these configurations, can be shared with non-LLE operation, and that goes for voice, data, and control signaling. Final point, conventional has, and I already made it, I want to reiterate it. Conventional has no control channel, no registration, no affiliation, no call processing, no mobility management. The conventional radios, I pick a channel and I hit the button and off I go, with or without LLE, based on how my radio is configured. So all this key management stuff, all this protection stuff, same thing applies in conventional. It will work a little bit differently because there's no control channel. And so let's leave it at that, at least for today. Any questions?
Any other questions before we close? All right,
Nope.
so thank you all.
Thank you all for your attention.
Thank you
Appreciate it.
all very much for your time, and thank you all for those of you who participated as well. Good turnout. Thanks. Have a good rest of the day and week.